In this next part, we will deal with a somewhat more advanced topic in subtypes and supertypes. We introduce the theoretical notion of the universal relation at the top of a subtype-supertype hierarchy. It is like a single table which includes all of the entity instances in a user domain. It is only of theoretical interest, but still helpful to our understanding of subtypes and supertypes. We often speak of a subtype-supertype hierarchy, which assumes only a single supertype for each subtype, the way it is handled in most modeling schemes. When you introduce multiple supertypes, sometimes called multiple inheritance, the structure is more accurately called a partial lattice. After a comparison of how 6 different modeling schemes handle subtypes and supertypes, we will summarize the benefits of modeling with subtypes and supertypes, and finally give you a bibliography with some of the more notable historical articles on subtypes and supertypes.
There is this, I've been speaking of it as a hierarchy, but it's not actually a hierarchy, subtypes and supertypes. What we're doing as we move up this hierarchy is that we are putting members of subtypes into bigger and bigger supertypes. When we get to the very, very top of this, that includes all things, instances, in one population. Can you see that theoretically that's a possibility? I could put all of my invoices, my employees, my products, my whatever, doesn't matter. I'll put them all into one population. Now, I'm going to have a bunch of attributes, aren't I? Because I got to include all of the attributes that are descriptors of each one of those all together. So how many attributes am I going to have? A long list. And will those attributes be meaningful for the rows? I'll take a very small subset of the attributes that will be relevant for any given object instance in this big table, if you like. At the other extreme, remember I said early on that putting object instances into a population is something of the designer's choosing. There is a certain degree of artificiality, if you like, in the formation of populations. The world isn't naturally that way. We impose that view on the world. We decide that a cluster of people that work for the same company are going to be considered, quote, employees. Okay? If you don't work for that company, and if you're not a person, then you don't belong in that population. But we're the ones that decide how to put them and how to set up those populations. Okay? So let's throw out the whole notion of typing, of forming populations. All we've got are a bunch of individuals. That's the bottom row of this triangle. So every instance is basically its own type. You can think of there as being n types or no types. I don't care which one it is. And these are like the boundary conditions of this thought. It's exactly the same as dividing by 0. Okay? You know how you do division. Division is you dip in and you take out n. That's whatever the divisor is. Okay? And if you're going to dip in and take out 0 every time, how many things are in the bucket? You have no idea, and you can't determine that. It's indeterminate. Same situation here. So we've got no types or n types. And then we begin the process of clustering into populations, and then for generalization we cluster into higher level populations and higher level populations. And at some point we may split and have multiple supertypes on a subtype, as right here. But there's an interesting rule here, and that says that at some point further up in this hierarchy, they have to come back together again. So that's what we're trying to depict in this diagram. And that's why we call it a lattice. In fact, it's I don't know, I dug through some of the mathematical literature and I can't find, there is a lattice, but in a lattice there's a single point both at the top and the bottom. So this is like a half a lattice or a partial lattice, because we don't come to a single point at the bottom, we only come to a single point or single population at the top. Moving up is the process of generalization, moving down is the process of specialization. Okay? In the OO world, everything has to be an object, and there is the root class. In a pure OO system, there's the root class, which is the population of all objects. Well, here's some of the verbiage of what I just went through. If we had at the top level a table of every row is something, some instance of something in our world, okay? That's called the universal relation. It's been called that in the literature, the universal relation. Single table for all the data in your case. What would be the entity? You couldn't tell. All you could do is say it's a thing in my world. Okay. What would be the identifier? Well, you'd probably have to come up with an artificial one in this case. There's nothing going to be relative to all the instances. Now, this is why I'm showing you this pyramid or this triangle. The real art of database design is choosing the level at which you're going to represent tables or entities or populations. Okay? That's the real art. So if somebody comes along and says, we're going to set up an employee file, the next thing you're going to want to find out is, what's the criteria for inclusion? What are you including and what are you excluding from that population you call an employee? What about retired employees? What about furloughed people? What about people on leave? What about prospects? What about people who have been given an offer to join the company but haven't yet joined the company? Okay? You have to answer all of those questions, and what you're trying to do is to determine what is the population, at what level. When we were, in our church, we were setting up a membership record. Question, do we include non-members or visitors in that table? Well, we can or we can't. It doesn't matter. It's our choice. But we have to decide, and it has to be clear. There's lots of commonality, isn't there, across members as well as visitors in that case. So, the real strength, and this is why I consider subtype supertypes to be such an important construct, is that it allows the designer to defer where they're going to build their tables. And that's really important. You don't have to putz the question. If the user comes up to you and says, oh yeah, but we've got this subset, yeah, okay, let's define a subset. There's something special we want to do with that. Remember the two rules. When you move up to the supertype, you have to be able to have more in the population, and when you go down, you have to be able to have more in the attributes. Okay? If there's nothing special or different that you want to do with a subset of the population, then you don't call out a subtype. Okay? So anytime the users express this, I'm doing something special with, then you can call it the subtype. And later on, you can decide where you want to build your tables. Okay, the notion of single versus multiple inheritance. Single inheritance, every subtype has at most one supertype. If that were the case, you would have a strict hierarchy of types. But in general, we could have multiple shared supertypes for a subtype. If multiple supertypes, they must converge on the population higher up in the root, I said before, and that's, call it a partial lattice or something. If you didn't have that, what would be wrong? If you had two supertypes above a subtype, everything that's in the subtype has to be in both of the supertypes. So at some point, that thing, instance, has to come together in one population at some point. Okay? A lattice is a partially ordered set in which every two-element subset has both the least upper bound and a greatest lower bound. And that's why in the concept of a lattice, you come to the least upper bound and the greatest lower bound. So you come to one population at each end. There's no lattice if there's no overlapping subtypes. It's possible to transform multiple inheritance lattices to a generalization hierarchy by defining all possible combinations of subtypes. Okay. Each mini hierarchy has a root, thus a partial lattice. All objects are disjoint. Well, okay, that's probably more than you ever wanted to know about this. But my point is that there is this hierarchy of subtypes, supertypes. Most modeling schemes do not entertain the idea of having multiple supertypes because it leads to too much complexity. But all I'm trying to tell you here is that it's possible. So, extreme entity generalization would be that universal relation at the very top of that pyramid. And here's what Graham Simpson came up with. He says, the level of generalization is critical. And he had Robin Wade was a cartoonist, and he would give him ideas, and Robin Wade would put together a cartoon for that. And so here you are. Are you sure you're not taking this generalization concept a bit too far, Norm? But that would be what you're seeing there as thing and a many-to-many reflexive relationship on it. That's exactly what would be at the top level of that hierarchy. What is the thing? So here's some various modeling schemes that do include the notion of subtypes and supertypes. Now the detail here isn't that important, but let me just say we've got disjoint versus overlapping. That's the exclusivity characteristic. We've got a total versus a partial covering, if you like, or that's the dependency characteristic. And so we're looking at each one of them. Toby Torrey's, Terry Halpin's that we have in our textbook, the UML stuff, the ODL, Object Data Language, which is part of the ODMG, Object Data Management Group of OMG, and then SQL 1999, which incorporated some object-oriented notions, including this notion of subtyping and supertyping. So you'll see some of them have a default of either overlapping or disjoint. For some of them, there is only one possibility. You can't define the other. Okay? I'm not going to expect you, of course, to remember this, but all I want you to see is I want you to have the big picture of what subtype supertyping is all about, and then be able to recognize if you're using a particular modeling scheme of what it allows and what it doesn't allow, the limitations. Okay? Benefits of subtype supertypes. We can consciously and creatively think about commonalities and about special cases and model them. That's significant in and of itself. Greater flexibility to handle extensions, greater stability for long-lived critical applications. You've just got a lot more flexibility when you're talking about using subtypes and supertypes. Generalization can reveal common patterns. Abstraction for presentation, we can collapse the subtypes into their supertypes. This is the equivalent of leveling, what's known as leveling in the process world. You're probably all familiar with DFDs where you take a process and you explode it, basically. They call it leveling. Well, subtypes and supertypes in the database world is exactly the same process. We use subtyping to aid human understanding with no intention of implementing as separate tables. Sometimes you can just use subtyping, supertyping, and it's to try to reflect what the users are telling you. Okay? We can approach the design top-down, bottom-up, middle-out, whatever. Explicit representation of multiple table designs, thus deferring the choice of where to build tables until later implementation. Okay? And if you want more information in there, I've got a reference to Graham Simpson's book. He deals with the whole notion of sub. In fact, his chapter on subtype and supertype, I think is chapter 4 in his book, out of many chapters. So he talks about this very early in the process. And that's, to me, a reflection of the fact that subtyping and supertyping is very important. I don't know if I ever told you, but and whether I mentioned this, but I considered Graham Simpson's book, and he's in a second edition, to be the best book in record-based modeling that's out there right now. He's a practitioner as well as a good thinker in all of this, so he has practical guidance, practical experience, because for years and years through Simpson and Bowles, they built, under contract, they built databases for people. It's really accurate in a lot of the things that he says, and not only the accuracy, it's accompanied by practicality. Last thing, I mentioned the Smith and Smith paper. That was the one that sort of kicked off this whole notion of abstractions. Chris Date's paper on subtype supertypes, Halpin's text, Simpson's text, and others have talked about this too. I give you a caution with Len Silverstone's book, or when he talks about this, he uses the term abstraction when he's talking about generalization, and that's true of Steve Huberman too. Steve and I have gone back and forth in this question. I say, Steve, you're calling it abstraction when it's really generalization. To me, abstraction means leaving things out, and we'll see that in our next lecture. That's all you ever wanted to know about subtypes and supertypes. Just be alert that there's a lot of misunderstanding out there regarding subtypes and supertypes. So when you're in doubt or when you hear, come back to this lecture, come back to these notes and see what you're seeing.
I hope this theoretical notion has been helpful in your understanding of subtypes and supertypes. Notice that the model of thing in the cartoon is precisely the universal relation. In the last part of this series, we contrast modeling subtype-supertype populations with the notion of inheritance and reuse in the context of object-oriented system design and software construction.